Okay, so for our unit circle, I'm going to, this isn't like with a particular color or anything, but I'm going to extend these lines over here for the axis points so that we can see where our x and y axis is. So now I've made it so it kind of looks like we're on a coordinate plane, which will be relevant in a minute. I'm going to do stuff before we do that. So I'm going to start with the absolute easiest thing, and that is degrees. So that's going to be one color. I'm using red, but I have no idea what colors you picked, so it doesn't matter. So our starting point is always right here on this line. So I'm going to do my degrees on this inner part of the circle. So this right here is 0 degrees. Then this first line is 30 degrees. The next line is 45 degrees. This next one is 60 degrees. And then straight up and down is 90 degrees.
So like on the line?
Yeah, so on the y-axis basically is 90. So it's 30 degrees between the axis points and the first one, and then it's 15 between those for the sake of counting it. So then over here, 30 more. So this is 120 degrees. The one in the middle over here is 135 degrees. The next one is 150 degrees. And then the x-axis is 180 degrees. And if I keep going down here, we add 30 more, so that's 210 degrees. Next is 225. Then we have 240 degrees. And then the y-axis on the bottom is 270 degrees. Add 30 more. We have 300 degrees. So 315 degrees. Another 15 degrees is 330 degrees. And then all the way back around to the x-axis, so the underneath side here puts you at 360 degrees. So most often people forget to write the 0 and the 360, but you have to have both to get all the points for the degree part.
I think I wrote them upside down.
Huh?
On the right side.
Did you rotate it? Did you like do this when you were writing?
Yeah.
That's fine. Some people do that. I just do it this way so I don't have to rotate it and y'all can read it the whole time.
It's just for 3 of them. The rest of them are
Okay, so that's all the degrees. So again, between the axis and the first line, these are 30 degrees. Okay, so then like from here to here, here to here, those are all 30 degrees. But in between these smaller lines that are together closer, there's 15 degrees between them. So for the sake of counting, that's how you would count them. It's 30, 15, 15, 30. It goes around like that all the way around. All right, changing colors. Now we're going to look at something we call radians, okay? So all of these are going to have a pi in them, okay, the pi symbol. I'm probably going to write them all, and then I'm going to show you how to count them, because it's just easier to do it that way. So this first one here, we start with 0 always. So I'm going to do these farther out toward the circle just so that they're not confused with the other stuff. Then up here, we've got pi over 6. Next I have pi over 4. Then I've got pi over 3. Pi over 2. Then 2 pi over 3. 3 pi over 4. 5 pi over 6. And pi. Then coming down here, 7 pi over 6. 5 pi over 4. 4 pi over 3. Then all the way down the bottom y-axis is 3 pi over 2. Continuing on, we've got 5 pi over 3. We've got 7 pi over 4. 11 pi over 6. And all the way around we have 2 pi. So I'm going to go up to the board and show you how to count them. So we start at 0 again always. Commonly people forget to write 0 and 2 pi, so just make sure you always get both of those. This should be the easy part of points, like in here. This should be the part where you to get most of your points because it's easy to count it. Once you understand how to count it, you're probably like, what in the world are you talking about at the moment? So I'm going to start with the absolute easiest ones, and those are increments of pi over 2. So we have 0, 1 pi over 2, 2 pi over 2, which reduces to pi, 3 pi over 2, and then all the way back around we have 4 pi over 2, which reduces to 2 pi. So the axis can be counted in increments of pi over 2. So every axis you just add 1 and then reduce the fraction down. Pi over 4s are probably the next easiest because that just divides these segments again. So pi over 4s are increments of 45 degrees. So every 45 degrees we have another pi over 4. So we start at 0. I have 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4. Over here I've got 4 pi over 4, which reduces to pi. Keep coming down, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, and then 8 pi over 4, which reduces to 2 pi. Okay, so those are probably the, oh gosh, don't go off. So those are probably the easiest ones, like, overall. Now, the pi over 6s and the pi over 3s actually both get counted together and reduced, but I'm going to do pi over 3s first, and then we'll go back and we'll do pi over 6, but pi over 3s are going to get included in pi over 6s. So, start at 0, we have 1 pi over 3, so these are increments of 60 degrees, so go another 60 degrees, do 2 pi over 3, 3 pi over 3, which is just pi, 4 pi over 3, 5 pi over 3, and then 6 pi over 3, which is 2 pi. Now, pi over 6s count everything except for the pi over 4s. Okay? So we've got 1 pi over 6, 2 pi over 6, which reduces to pi over 3. 3 pi over 6, which reduces to pi over 2. 4 pi over 6, which reduces to 2 pi over 3. 5 pi over 6, and 6 pi over 6. Keep going. 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, which reduces to 3 pi over 2. 10 pi over 6, which reduces to 5 pi over 3. 11 pi over 6, and then 12 pi over 6, which reduces to 2 pi. Okay? Now you're probably like still a little confused, I'm assuming, because, you know, you've never seen this before. If you can memorize, what I'm going to tell you is once you memorize one quadrant, the rest of it just kind of follows with everything else that we do. The other thing to remember is there have to be that many segments in half of it. So there were 6 segments for the pi over 6s in the top half, and then there also has to be 6 in the bottom. So when you're doing pi over 4s, you should have 4 segments that you're counting. Pi over 3s, we have 3 segments. So 1, 2, 3, just for the sake of like you being able to count. Okay, I could have you do, no, this is all that goes on the unit circle, but I could have you do, you know, pi over 8s. There would be 8 in the top, but you don't need to worry about that. You just need these ones that are on here as known values. Okay. Alright, so I'm going to go on and I'm going to put axis points on over here on the axis, these are all going to be ordered pairs. So here, my ordered pair is 1, 0. Up here, it is 0, 1. Okay, so these are just XY values of an ordered pair. Over here, -1, 0. And then down here, 0, -1. Alright, now this next thing that I'm going to do, you do not need to write on there. I'm just going to do this to help you see something. I actually don't know if that's going to be visible. Alright, so I'm going to erase this off in a second. This is just for visualization. So at every one of these points, I'm going to have an XY ordered pair, okay, which is ultimately going to give me a sine and a cosine value for all of these values, which is what you asked earlier. How am I going to use this? Like, am I going to use this to do homework problems? Yes, because we're going to be using those values to answer questions. So out here is 1. So my radius of my circle is 1. Okay, so that means that every value otherwise has to be less than that. So this value here is dropping down. It's not super far from 1 visually, and this one here is ballpark around 1/2. Obviously, it's, you know, the line's not drawn perfectly. So I'm going to get rid of this. Let's see. I'm going to go with orange for right now. So my pi over 6s, the values are going to be root 3 over 2 for x and 1/2. Now, if you were to type root 3 over 2 into your calculator, you would see that it's equal to approximately 0.866. And so that's what that value is when I say, okay, it's almost 1, or just a little shy of it, so it's a little over 8.5. Like, you know what I mean, 0.8. So then at every increment, I say every increment, at every one where a pi over 6 is explicitly written, so anything that has a 6 on the bottom is going to be the same values, but the sign is going to change on it. Okay, so if it's positive or negative. So right now, both of these are positive. because up here, x is positive and y is positive. Okay, on this side, though, if I actually write it, x is negative, but y is positive, so it's going to be negative root 3 over 2 and 1/2. Down here at 7 pi over 6, x is negative and y is negative, so it's now going to be negative root 3 over 2 and negative 1/2. And then over at 11 pi over 6, x is positive, y is negative, so it's going to be root 3 over 2 and negative 1/2. So you'll notice all the numbers are the same for the pi over 6s. It's just the sign is changing. And you should know that. I mean, that's back from like the first time you learned how to graph. You learned which x's and which y's are positive and negative. So now I'm going to change colors again and do the pi over 4s. And I do this so that when you go back to study and you look at the different colors, you can be reminded of what goes with what, basically. So pi over 4s. These ones, I'm going to draw, again, you don't need to draw this line. I'm just doing it to show you. This drops down or comes across, okay? It's a little bigger than 1/2, but it's closer in than the previous one that I had, okay, in both directions on the x and the y. The pi over 4s are the easiest ones. They are both root 2 over 2. So root 2 over 2 and root 2 over 2. And that decimal-wise comes out to like 0.707, I think. Let me check. I don't want to give you the wrong decimal. Yeah, 0.707. So then, over here at 3 pi over 4, x is negative, y is positive, so it's going to be negative root 2 over 2 and root 2 over 2. At 5 pi over 4, x is negative and y is negative, so they are both going to be negative root 2 over 2. Then at 7 pi over 4, x is positive, y is negative, so we've got root 2 over 2 and negative root 2 over 2. Alright, I'm going to do pink for the last ones. Or for the last values. We still have to do one more thing on this after. But, alright, so the increments of pi over 3, dropping down. We've got, again, up here, the y direction, we're almost to 1. In the x direction, that's about 1/2, or it looks, visually looks like 1/2. So, these values are just the inverse of the pi over 6s. They're just flipped. So it's 1/2 and root 3 over 2. So then at 2 pi over 3, x is negative, y is positive, so negative 1/2, root 3 over 2. At 4 pi over 3, both are negative, so negative 1/2, negative root 3 over 2. And Then at 5 pi over 3, x is positive, y is negative. So this is going to be 1/2 and negative root 3 over 2. So there's one more thing. Well, actually, let me put the last thing on here before I go up there and show you the trick. So change colors one more time. So right now, okay, cosine is going to be associated with x. Let me write this up here. Cosine is x, sine is y, tangent then is y over x. Huh? You can, you can just leave room to write around the edge here again, because we're going to write one more thing there. But that way you have it. So the cosine of 30 degrees is root 3 over 2. Okay, it's the x value. The sine of 30 degrees is 1/2. Okay, so cosine is the x value, sine is the y values. Tangent, though, however, is y over x. So that means I take the y fraction, okay, the sine value, and I divide it by the cosine value. So in this case here, I would be doing, like, I'm going to write it over here to the side, then I'm going to erase it. So if you want to have, like, the math, you might want to, like, write it on the back just so you have it. But you can also just memorize the answers. But I would show you how to get it in case you forget. So y over x, so we have 1/2 divided by root 3 over 2. Then, keep, change, flip, I would get 1 over 2 times 2 over root 3. 2's cancel, leaves me with 1 over root 3. Or when we rationalize, it becomes root 3 over 3. Okay? Now, don't worry, we will do more with this later. I just wanted to show you. So that one is root 3 over 3. Now, every single pi over 6 is root 3 over 3. The sign just changes. Okay? So y was positive and x was positive, so my tangent value is positive. Over here, y is positive, but x is negative, so this is going to be negative root 3 over 3. Down here, y is negative and x is negative, so it's going to be positive root 3 over 3. Then over here, y is negative, x is positive, so this is going to be negative root 3 over 3. Now at pi over 4, we would have root 2 over 2 divided by root 2 over 2. Keep, change, flip. We have root 2 over 2 times 2 over root 2. Everything cancels, and that leaves us with 1. So at all the increments of pi over 4, it's going to be 1. The only thing that changes is the sign of it. So over here, 1 is negative, 1 is positive, so this is going to be negative 1. Down here, both are negatives. This is going to be positive 1. Over here, 1's negative, 1's positive, so this is going to be negative 1. Then the last ones, we've got root 3 over 2 over 1/2. So keep, change, flip. Root 3 over 2 times 2 over 1. 2's cancel, leaves us with root 3. So this is going to be root 3 here. So then over here, 1's negative, 1's positive, so negative root 3. Down here, both are negative, so it's going to be positive root 3. And over here, 1's negative, 1's positive, so this is going to be negative root 3 down here as well. Now, the last ones are the access points for the tangents. So I still have 4 more tangents I need here. So it's y over x. So right here, it would be 0 over 1. Which what is that? 0 divided by any number is 0 divided by 0. So these tangent values are 0 on both axes, okay? Because 0 divided by 1 is 0, 0 divided by negative 1 is 0. But up here, I have 1 divided by 0. What happens when I divide by 0?
0.
No. Huh? It's undefined. Sometime ask Siri why or what 0 divided by 0 is. You've never done that. It's kind of funny.
What did she say?
Something about you have no cookies and Cookie Monster's sad and you have no friends. It's really funny. I guess she still says it. I don't know. I haven't asked her in a while. Anyways, okay. I'm going to save this so it doesn't disappear. Okay, so now I'm going to show you my little trick. Nope, come on. There we go. Okay, so you have 5 fingers on your hand.
Yes.
Because all of you have normal hand. So, if you put it down, other hand. Okay, obviously your hand's probably about as big as your paper, so probably isn't going to work super well on top of your paper. But each finger here lines up with a piece on this circle. Okay, so my thumb is on the x-axis all the time. Okay, my pinky is on the y-axis all the time. Okay, my other 3 fingers split nicely so that my pointer finger is on the pi over 6s, my middle finger is on the pi over 4s, and my ring finger is on the pi over 3s. Okay, so if I memorize this hand right here, then all I have to do is flip it, and it's still lined up. Okay, now you're going to break your shoulder in the process, but I come back here, the values stayed the same. The only thing I have to know is basic math of where's x and y positive and negative. So if you memorize this one, you're going to know all 4. Okay, so you start here, hand like this, flip it backwards. Okay, your pinky's going to stay on the y-axis the whole time, thumb staying on the x-axis. Okay, so it's, oh, it'll go off. So it's front to back. Then you're going to take your hand and flip it upside down. My shadow's covering the screen, but notice thumb is still on the x, pinky's still on the y, it's just now upside down. Okay, so the fingers still line up, and then we flip it back again to get the last one. Okay, so what I tell people all the time is I had a friend in high school who she was having a hard time memorizing it. Our teacher showed us this hand trick, and what she did is she wrote, basically, she took and wrote on her hand to help her study. She wrote like pi over 6, pi over 4, pi over 3, pi over 2. And then that's how she knew what increments they were. So she wrote like 0 and 2 pi here. Then she wrote these x, y values on her hand to help her memorize it. So she could just think, all I have to do is flip it and change the sign and memorize it that way. So are we going to have a quiz where it's just a blank piece of paper we write? Yeah. What you started with today is what you will start with for the quiz. Yeah. It's a lot, but you have to know it.
When is it?
Friday is going to be the practice quiz. Tentatively, I might change it. But Friday is going to be the practice quiz. Monday or Tuesday will be the real one.
But we get 100 on Friday.
You don't have to retake it. And you can possibly get over 100. Yeah, if you don't get 100, I make you retake it.
What if you don't get 100 on the actual?
I take the higher one. So I don't even put grades in unless it's 100. And you can get 66 out of 64. So there's 66 things on here you have to know, but I graded out of 64 to basically give you leeway to miss 2 things. Now, if you are more of an audible learner and you like music, somebody out there, not me, wrote a song, a unit circle song, that has all of these lovely things in it. I'm not sure that it does tangent values. I'm thinking it doesn't because Christian, I think, had listened to the song and forgot to do tangent values at one point, so it might or might not have tangent values. But it has everything else in it. If you just like go on YouTube and you search the song, but it sings it to you. The guy's voice is a little weird. I'm gonna warn you, but some people are more audible, so they like to do it that way. I'm gonna give you in just a second another blank copy so that you can practice. If you like Google, that's what I did to get the screenshot here from my iPad. What is happening? But if you Google like blank unit circle, it'll come up with pretty much this exact one in terms of how it looks for you to practice that way also. But if you're like, I need to do this like 10 times, I need more unit circles to practice, come see me and I'll give you more. So, any questions in the immediate short term? I know it's a lot, but it follows a pattern. So if you memorize one, you've got all of it. So you should break your arm off in the process.